Okay, welcome to lesson 17 of additional maths with Mr. Barrow. Okay, remember that when you watch these videos, if you have any comments to make, if I make any mistakes, please feel free to comment underneath. All mathematicians make mistakes, and it is important to those mathematicians that they are corrected. Okay, so here is what I want to do today. I want to teach you how to solve trigonometric equations where the trigonometric equation is more complex than just sine x equals 0.3, find all the solutions. Okay, so we'll be looking at examples which form quadratics, and we're going to be looking at examples which have multiple angles within the function. Okay, before we do though, we need to make sure we know the trigonometric identities, and we also need to make sure that we can factorize well. Okay, so firstly, factorizing. Pause the video and have a go at factorizing these 5 quadratics here. Okay. Well, 2 of them are quadratic, 3 of them are quadratics in a way. Okay, 2 of them are normal quadratics, and the others are sort of related to the quadratic world. Okay, so work your way through them. Try and see if you can factorize them. Pause the video. I'm going to show the answers. So, first one, we'll factorize into 2x at the start of both brackets. Sorry, start of first bracket, and x in the start of the second. And it'll be 2x negative 3, x plus 2. Okay, because minus 3x plus 4x will give you plus 1x. And minus 3 times 2 is minus 6, and 2x times x is 2x squared. And the others all form the same pattern. The second one is exactly the same as the first, but with a's instead of x's. Okay. The third, here, the thing that is squared and that is on its own is b squared. So you've got b squared there, and then you've got b squared squared, which gives you b to the power 4. So in effect, your b squared has replaced what was the a and what was the x. So it's 2 lots of b squared minus 3, and then b squared plus 2. Okay, that would factorize it. The fourth one is the same, but instead of the a and the x, we have lambda to the power 5. Lambda is a Greek letter, which you will meet lots at A level, especially when you're dealing with vectors and things like that. Okay, so you have 2 lambda to the power 5 minus 3, and then lambda, sorry, that's an a, not a lambda, and then lambda to the power 5 plus 2. Okay, the last one is what I want to focus on. A lot of mathematicians say, well, we should rewrite this as 2a squared plus a minus 6 before factorizing, but I don't agree with that. I think we should just factorize it as it is, and your variable is sine x. Okay, sine x is on its own there, and sine x is being squared there. So when you factorize it, you get 2 sine x minus 3, and then sine x plus 2. Okay, so you need to feel confident at factorizing trigonometric expressions like that. Okay, that'll be key to success in this topic. And then a quick reminder of the trigonometric identities that we learnt in previous lesson. So you know that tan x can be replaced with sine x over cos x. That is an identity that is always true. Tan x is defined as being identical to sine x divided by cos x. And the other trigonometric identity is that sine squared x plus cos squared x is always equal to 1. Okay? And remembering that sine squared x means sine x times sine x. It's sine x all squared. It's not just the sine bit that's being squared. That would be meaningless. You can't square the function sine. You have to square sine of x. Okay, so it's a mathematician's shorthand for writing sine of x all squared. So let's get on with the worked example here, trying to solve this trigonometric equation. In order to solve this trigonometric equation, the best way is firstly to think, right, do I have one trigonometric function in my expression? And no, we have cos theta and we have sine theta. So we've got to think, is there a way of rewriting this so that we have one trigonometric function? Well, we know that sine squared theta plus cos squared theta is equal to 1. So as that's true, since sine squared theta plus cos squared theta is always equal to 1, then I know that sine squared theta is always equal to 1 minus cos squared theta. And so what I'm going to do is I'm going to replace sine squared theta with that expression because they are equivalent. And then that will leave me with just cosine throughout the equation. And so that's one trigonometric function, so I can solve the equation. So my next line will be 2 lots of 1 minus cos squared theta plus 3 cos theta minus 3 equals 0. I expand, simplify, so I get 2 minus 2 cos squared theta plus 3 cos theta minus 3 equals 0. I prefer, this looks like a quadratic sort of expression. I prefer it if the quadratic, the coefficient of the squared part is positive. So I'm going to add 2 cos squared theta to both sides. And in fact, I'm going to make the left side equal to 0. So I'm going to add 2 cos squared theta. I'm going to subtract 3 cos theta. I'm going to add 3 and subtract 2. So that's plus 1. Now I've got an expression that I can factorize and solve. If 0 is equal to 2 cos squared theta minus 3 cos theta plus 1, then 0 is also equal to its factorized equivalent. And we've learned that we can just replace, we can just factorize it pretending that the cos theta is our x. So we've got 2 of our x squared. So here's 2 of our 2 cos theta times cos theta would give you that. And then if you multiply minus 1 by minus 1, you get 1. And then minus 1 cos theta and minus 2 cos theta will combine to make minus 3 cos theta. So that is the factorized form of that expression. Now we have it in factorized form, I can state what cos theta can equal. Because this bracket multiplied by this bracket equals 0, this will be true when either bracket is 0. The first bracket is 0 when cos theta is equal to a half, because 2 lots of a half, take away 1 would be 0. The second bracket will be 0 when cos theta is equal to 1. Now, I can use that now to help me find out what theta needs to be. I want to solve theta between 0 and 360 degrees. And I know that I want to find the values of theta such that cos of theta is a half or cos of theta is 1. So at this point, I draw a graph like I did when I was solving trigonometric equations in the previous lesson. And the graph will help me decide what values I have along with my calculator. So I'm going to draw it between 0 and 360. So there's 360, there's 180, there's 90, there's 270. Sorry, 180 there, not 90. So now, firstly, I want to find out the values of theta which give me half. So if cos theta is a half, that'll happen at this angle or at this angle here. And cos theta is 1 will happen much easier at this angle, which is 0, or this angle, which is 360. So the answers from this part are quite simple. So theta is either 0 or 2 other values, which I'm going to get from the half, or 360 degrees. So from the half, I'm going to get the values from that by just doing, if cos theta is a half, then theta is cos to minus 1, the inverse of cos of a half. And my calculator gives me that as 60 degrees. So that value there is 60. And then I think, well, I know this graph is symmetrical, so if that distance is 60, then this distance will also be 60. And hence, if that number is 60, then this number is 300 because it's 60 degrees below 360. Okay, and those are my 4 solutions. So I have 0, 60, 300, and 360. Okay, so I'm now going to give you a chance to have a go at one similar example yourselves. So have a go at solving this. I want you to solve this between 0 and 360 degrees. So solve for x between 0 and 360 degrees, the following equation. 2 cos squared x minus sine x minus 1 equals 0. So pause the video, have a go at solving that, find all the solutions. For a hint, there are only 3 solutions in this one. Okay. All right, hopefully you've had a go. So the first thing is you replace cos squared x with 1 minus sine squared x. So that becomes 2 lots of 1 minus sine squared x minus sine x minus 1 equals 0. Expand, simplify, and make the sine squared x part positive. You get 0 equals 2 sine squared x plus sine x minus 1. So if you've expanded, simplified, and rearranged the equation, that's what you should end up with. At this point, you can factorize. So it becomes 2 sine x as the start of one bracket, sine x as the start of the other bracket. And it's 2 sine x minus 1 and sine x plus 1. So therefore, sine x is either equal to a half or sine x is equal to minus 1. At this point, you draw your graph. You draw your graph of sine x between 0 and 360 degrees, which looks like that. 180 there, 90 there, 270 there. Make sure you're getting faster and faster at sketching your trigonometric functions. So we've drawn the graph of y equals sine x, and we want to know the angles that give you half height. So that'll be that one, and that one between 0 and 360. There aren't any others. And minus 1, which you can see straight away, is 270. So your answers for x are 2 values and then 270 degrees. Okay, 270 degrees comes from sine x is minus 1. And the other 2 values, firstly, you do x is the inverse of sine of a half, which is 30 degrees. So this number is 30 there, which means, if we zoom a little bit, that distance is 30, so hence that distance is also 30 from the symmetrical properties of the graph. And so we've got 150 as the other value. So my 2 values there are 30, 150, and then the final value is 270. So those are my 3 answers to this equation. If you got those 3 right, well done. Okay. Now, I'm going to show you a different type of trigonometric function and how to be very careful when you're solving it. So let's say you have this one. Solve between 0 and 360 the equation tan of 2x equals 0.5. Now, whenever you've got this, you have this function there, tan of 2x equals 0.5. What you should do is you should solve and find all the possible values of 2x. So think of it as simply tan of theta is 0.5, and you're solving for theta. If you want to find the values of x between 0 and 360, then you know the values of 2x have to be between 0 and 720. So it's in effect, you're trying to find the answer for what 2x could be between 0 and 720, and then you'll halve each of those, and then you'll find x between 0 and 360. So I say, let 2x be theta, okay? So I'm going to replace 2x with theta. So I'm solving tan of theta is 0.5. And that's simply, and this for theta between 0 and 720, okay, from 0 up to 720 degrees. So I draw my graph for tan theta between 0 and 720, and that'll look like this. Between 0 and 90, it looks like that. So then we have an asymptote. Then between 90 and 180 is like that, and then 180 to 270 is like that, then an asymptote. And then from 270 to 360 it looks like that. And then that'll repeat again. Okay. So that whole process will repeat again. So we'll have that there was 180, that there was 360. The next one will be 540. And the next one will be 720. So I want to find the values of the theta could be, okay, if the height is 0.5. So 0.5 is here. It'll give me one answer there, another one here, another one here, another one here. And all I need to do is find the first one, and then each one is 180 degrees further on, because the tan graph repeats every 180 degrees. So to find the next one, add 180, find the next one, add 180, find the next one, add 180, and there should be 4 in total. The first one will be found from your calculator. If tan theta is 0.5, then theta is the inverse of tan of 0.5, which gives you 26.5 something, rounds to 26.6, but I'm not going to round until the end. Okay. So therefore, theta is 26.5 dot dot dot. The next one, 206.5 dot dot dot. The next one, 386.5 dot dot dot. And the next one, 566.5 dot dot dot. At this point, you can say, right, I found all my values of theta. Theta, remember, is 2x. Now I'll find all the values for x. Some people are tempted to find the first value of theta, 26.5, halve it, and then find all the other values of x. And in that direction lie many mistakes. So I would really avoid it. Find all the possible values for 2x or theta, as it were, and then find all the values for x. So the solutions are to one decimal place, 13.3 degrees, 103.3 degrees, 193.3 degrees, and 283.3 degrees. So those are your 4 solutions between 0 and 360 degrees, solving tan of 2x equals 0.5. So now, have a go yourself. This time, again, between 0 and 360 degrees, solve for x between 0 and 360. The following equation. Cos of 2x equals negative 0.7. Find all the solutions you can. So pause the video and have a go. If you want a hint, you should have 4 answers at the end. Okay, I'll run through the answer. With this, if you're finding x between 0 and 360, then 2x will be between 0 and 720. So I'm going to draw my graph for cos between 0 and 720. Okay, so between 0 and 360, it does this, and then it'll repeat again between 0 and 720. So that there is 720 degrees, that there is 360 at the halfway point. And we want negative 0.7. So negative 0.7 is there. So we want 1, 2, 3, 4 answers. Okay. And the way to find them, you'll find the first one using your calculator. That will give you that one. And then the distance for the next one is 360 minus that. And for each of those, you just need to add 360 to get the final 2. Okay. So in effect, 2x, you do cos to the minus 1 of 0.7, of negative 0.7, and that gives you 134.42 dot dot dot. So 2x is either that, 134.4 dot dot dot, or the next one, 360 minus that, which is 225.5 dot dot dot. Next one, 494.4 dot dot dot. And the next one, 585.5 dot dot dot. And then when you divide by 2 to find all the values for x, and then round to one decimal place, you get 67.2 degrees, 112.8, 247.2, and lastly 292.8 degrees. All of those to one decimal place. If you manage to get all of those correct with no mistakes, that's superb. Okay. At this point, what you should do is you should have a go at exercise 8.4, the fourth exercise in chapter 8 from this wonderful textbook. Try and develop your fluency, try and develop the ability to solve what look like quadratic equations involving trigonometric functions, and questions like the last two that we did, which were based around sort of double angle questions, and then have a go at questions 9 and 10 if you can answer those correctly. Okay, so go away, enjoy your maths, develop your fluency, become mathematicians, okay, where you do these things without thinking because you have practiced them and they are then part of your skill set. Off you go and enjoy.